For this worksheet on graphing quadratics or parabolas from a function table, I'm going to model kind of some main ideas in the first three, and then you're going to try the next six on your own. One thing that's going to be really important to pay attention to today is sign, being really careful with order of operations, and if an equation isn't in standard form yet, making sure that you really carefully evaluate it so that it is. You could leave it alone, but I think it's going to be a good habit to start by squaring and then multiplying by that negative to get to that ax squared plus bx plus c form. One thing I want to point out about these domains, it is using function notation. So we have x being applied, we have f of x, we'll find the output, or y. Normally with a domain, we've practiced that we want to have negative values, 0, and positive, so that we have a complete picture. Here, they sometimes more strategically pick a domain so that you can see the graph's behavior better. So for today, that's fine. I'm going to start with this input 1. 1 squared is 1. Minus 6 times 1, 1 minus 6 is negative 5 plus 11. You could see where this math eventually could get a little bit tricky, especially with negatives to do in your head. So that's where one thing that might be helpful in your scrap paper is to make a 3-column table. My x value, here's where I'll do all my work, and that's where I'll find f of x or y. So if that's 1, my input's 1, I'm going to have 1 minus 6 plus 11, we'll be able to find the y value, plot the point, no problem. On the next problem, my advice would be, like I said, to square x plus 1. Hopefully you remember those special cases. If not, we know that it's the entire quantity being squared. I'd end up with x squared plus 2x plus 1. I need to then distribute a negative and add in that 3. So you have lots of options with how you're going to proceed with these, but the next thing I really wanted to show is how to be really careful with negatives. So I'm going to change colors for that third example. If I want to figure out what negative 4 squared plus 4 times negative 4 plus 1 is, this is another way to show your work. Really carefully, you know that negative 4 being squared is going to become a positive 16, plus 4 times negative 4 is a negative 16, and you still have that plus 1. Since these cancel, that outputs 1. I have a point at negative 4, 1. Get closer, and we'd continue from there. One thing you're going to notice with these graphs, they're all quadratic. They have that highest exponent of 2, or they have a degree of 2. That means you can expect parabolas, kind of a U shape that might open upwards or open downwards. So what you want to be thinking about as you go through these examples, and it's fine to use a calculator for the table, but is there any kind of patterns you can see? How do I know if it's going to be upward facing or downward facing? How can I figure out maybe some key points? What's my y-intercept, for example?